This is our review real quick. Grams to moles, moles to grams, you should know. So try to give this one a shot. How many moles are there in 6.5 grams of lithium? Try this one. Give this one a shot.
That's great.
Molar ratios, we talked about this again right before. Okay, so for instance, 2 moles or 2 atoms, same thing, of hydrogen to every 1 of oxygen to every 2 of water. So if you have 4 of hydrogen, you need 2 of oxygen and you'll make 4 of water. If you have 10 of hydrogen, you'll need 5 of oxygen, you'll make 10 of water. Right? So it's a 2-to-2 ratio, which is the same as a 1-to-1 ratio. Right? So these are always going to have the same amount of moles, and then this is always going to be half as much. Okay, just got to watch those ratios. So here we go. We did the same equation talked about last time. If you have 3 moles of oxygen, make me cough. How many moles of water can you make? So it's just like any other conversion problem, information times in a line. You have 5.00 moles of aluminum times in a line. You're trying to get to oxygen from aluminum. You know there's 4 aluminum for every 3 oxygen. So just 5 times 3 is 15 divided by 4 is 3.75. If I have 5.68 grams of silicon dioxide and excess HF, what mass of water will I make? So if I have 5.68 grams of this, how many grams of this will I make? This is a test question. That's all right. All right, let's go ahead and talk about how to do this. Okay, so if I have 5.68 grams of this, remember our little phrase, grams to moles, moles to moles, moles to grams. So we can't go from grams of this to grams of that, but we can go from moles of this to moles of that. So if you're going to do that, you got to balance it. So first step should always be balancing it. Let's see, put a 2 here. That means 2 hydrogen, 1 silicon, 2 fluorine. Nope, that's not going to work. Got to put a 4 there. So we have 4 fluorine, which means we have to put a 2 there. And now we have 2 oxygen, 1 silicon. So I think we're balanced now. So what we have here is we have a molar ratio of 1 of these for every 2 water. But we're not there yet, because first thing we got to do is turn this into moles. 5.68 grams times in a line, 1 mole. I have no idea how much that weighs off the top of my head.
60.09.
60?
60.09.
Okay.
It would be 28.09.
So if you do that, what do you get? 5.68 divided by 60.09. I had Panda Express last night.
0.0945.
No bueno for Panda Express.
Okay, what did you get?
0.094524879.
4 or 5. Okay.
No good. Like it literally means no good.
All right. So if you have 0.0945 moles of SiO2, how do you figure out how many moles you have of water? Double it, right? Times, there's 2 H2O for every 1 SiO2. So if you double that, what do you get?
0.189.
0.819.
Okay.
Sorry.
No, moles, sorry. And now turn this into moles, 0.18 or grams. Moles times in the line. 1 mole is 18 grams. What do you get? 3 point what?
More too.
Okay, there we go.
I got the wrong answer.
Okay. We've been saying 2 hydrogen to 1 oxygen to 2 water, right? And if I have 2 hydrogen, I'm going to have 2 water. And if I have 1 oxygen, I'm going to have 2 water and blah, blah, blah. But we've been ignoring them together. So think of it like this. If you have 50 moles of hydrogen and only 1 mole of oxygen, you can only make 2 moles of water. Does that make sense? Let me show you here. So I have all the little white things are all hydrogen. So let's say I have a big old handful here of hydrogens. I got a ton of hydrogens. And I got 1 O2. So I'm assembling myself some water. Cool. So take my O2, break it up, take some oxygen and some hydrogens, attach it, la da da. Alright, there we go. I made 1 water. Now come over here and attach some more hydrogens. Okay, I made a 2nd water. And now I go to make myself some more. I'm all out of oxygen. It's gone. It's all been used up to make these 2 waters. But I still have a handful of hydrogens left. So it doesn't matter. They just go unused. So even if I can have as much of this as I want, if I only have 1 oxygen, I can only make 2 water. The same thing can be said for anything you do. Really, for instance, the other day I went to make a sandwich. And I was really hungry. So I was going to make like 2 or 3 sandwiches. I think we've all been there. And so I opened up my fridge, and I took out like 50 slices of ham, just to, make sure. And I took out a brand new pack, a big old thing of Swiss cheese, and I took out a bunch of mayonnaise and mustard and horseradish. Yeah, I like some horseradish. You give me a break, all right? And some pickles, right? So I got this huge pile of stuff. My whole kitchen counter is just covered in all these goodies. And I go to my pantry, and I take out my bread, and I have 2 slices of bread. How many sandwiches can I make? 1. So, even though I have enough meat and cheese and condiments and everything to make 5, 6, 30 sandwiches, I only have enough bread to make 1. So, you can only make as much product as the smallest amount of your reactant will allow you to. Okay? Doesn't matter how much hydrogen you have if you don't have enough oxygen. So, give this one a shot.
Not really.
So, there's 2 ways to do this. The way that's quicker and easier, and the way that's longer. The problem is, to do the quicker, easier way, you have to really understand. You have to really understand the chemistry. You have to really understand math. There's a lot of stuff that needs to be going on upstairs. So, for a lot of you, it may not be the best choice. I'll explain it first, and then we'll do the little bit longer way, but the way you'll always get the answer right. So, if you look at this, you need 2 hydrogen for every 1 oxygen. Does that make sense? If you look at your numbers, you have 3 hydrogen and 2 oxygen. Do you have twice as much hydrogen as you do oxygen? No. That means you don't have enough hydrogen. Hydrogen is your limiting reagent, okay? Meaning you're going to be able to make as much water as hydrogen will allow, and oxygen is in excess. You have more oxygen than you're going to need. So, if you can make 3 moles of hydrogen, how many moles of water can you make? 3. Now, don't go plugging that in yet, because then you're going to make this go away. Now, let me show you the second way to do this. that is to do the problem twice. So assuming that each of your reactants is the limiting reagent. So let me show you. So assuming hydrogen is your limiting reactant, if you have 3.0 moles of H2, how many moles of water can you make? You just already talked about this.
3.
3. All right, now let's assume oxygen is the limiting reactant. If you have 2.0 moles of oxygen, how many moles of water can you make? 4. Okay, so it's just like the sandwich. If I have enough bread to make 2 sandwiches and I have enough meat to make 5 sandwiches, how many sandwiches can I make? 2. So I have enough hydrogen to make 3 waters. I have enough oxygen to make 4 waters. So how many waters can I make?
3.
3. Yeah. You always choose the smallest number. So do them both. Get your answer twice. And then you choose the smallest number. All right, give this one a shot. Now again, I just added one extra step. This one now you got to go grams to moles. But it's still the same exact thing. And luckily you all know how to do grams to moles. So, first things first, grams are no good at all. Got to turn these to moles. So 4.5 grams of hydrogen turns into how many moles of hydrogen?
4.46.
How about 2.25? Because it's H2. Okay, what about oxygen? What's that going to turn into?
0.65.
0.625. So, which one is limiting?
0.625.
Oxygen. Now understand it's not just because it's smaller. Because if this was 2.25 and this was 2, hydrogen would be limiting. Because remember, hydrogen has to be twice as much of oxygen. It just so happens that it's 4 times as much. So it's you got way more hydrogen than you're going to need.
So if it was like 1.
If it was, if this was like 1, then that would be limiting. So again, that's the hard way. That's a quick but hard way to do because you really got to know what's going on. The easier way is to do the problem all out with both of these numbers, and then whichever gives you the smallest answer. So we've gone from grams of our product, reactant, to moles of our reactant. Now we have to go from moles of our limiting reagent, which we've decided is this, so we can forget about this, to moles of, in this case, we want water. So, how do you go from moles of oxygen to just times 2, right? Because it's a 1 to 2 ratio. Does that make sense? So, times, you have 2 H2O for every 1 O2. You're going to get 1.25 moles of water. And now just turn those into grams. Times in a line, 18 grams for every 1 mole. And that's going to come out to be 22.5 grams.
Wow. I did not even get close.
First thing you got to do is turn these both into moles. So how many moles do these end up equaling?
12.42.
About 12.5 and what?
0.892.
Okay. And 0.892. All right. So this one is really obvious what your limiting reagent is, right?
Yeah.
Yeah, nitrogen. Because this is like 20 times as much, okay, not like 15 times as much, right? You need 3 times as much hydrogen, but this is like 15 times as much hydrogen, so you got way more hydrogen than you need. So it's this one that matters. So if you have that many moles of nitrogen, how do you figure out how many moles of ammonia you're going to have?
Multiply by 5.
Multiply by 2. Because there are 2 ammonia for every 1 nitrogen. Right? Do that, and you're going to get what? 1.78 moles of NH3. And then you just got to turn that into grams. So 1 mole equals how many grams? Say 17. All right. You multiply those together, and what do you get?
0.1.
No.
Oh, you multiply.
30.3.
30.3?
Yeah.
Okay.
How do you keep getting 0.1?
Because I divided.
So that's your answer. 30.3.